In the today's session, I am going to discuss the velocity and acceleration analysis using instantaneous center method. So, what exactly an instantaneous center method is? When you consider any machine or mechanism, there are a number of rotating parts. Generally, whenever we talk about the instantaneous center in a mechanism, the entire link is supposed to be rotating about an imaginary center or at a given center of at any instant it is rotating about a point. Such a center has a zero velocity or the link is at rest at this point. That means in a mechanism or in a machine when the elements are oscillating or reciprocating motion, entire link is assumed to be rotating about a fixed point. At that point, the velocity is assumed to be zero. This center is known as the instantaneous center. This center is known as the instantaneous center or the center of rotation. So, the locus of this instantaneous center in the space during definite motion of the body is called the space centroid. What is the space centroid? The locus of the instantaneous center in the space during the motion is known as the space centroid, whereas the locus of the instantaneous center relative to the link or the body is known as the body centroid. So, this is what the concept of instantaneous center. Once again, what is the instantaneous center? Instantaneous center is nothing but a link as a whole may be assumed to be rotating about a fixed point which is known as the instantaneous center. And second important point is that at this center the velocity is the link velocity is assumed to be zero. The next one is how we are going to do the velocity analysis, right, by instantaneous center method. So you can see here a link AB, you can see, right. So from A, draw a perpendicular, right, and from B draw the perpendicular, right. So they meet at the point I. For that, so consider the 2 points A and B on the link, right. So AB is the link and A is at A and B. What we are going to do? So actually, if you just see at the point A, the velocity of the point A is VA, the velocity of the point B is VB. So as the directions are shown in figure. So from these velocity positions, draw the perpendiculars and these two meet at a point which is known as the instantaneous center, right. So where I is the instantaneous center of rotation of the link AB. That means the link AB is assumed to be rotating about the instantaneous center I. Right? And we know that V from the V is equal to R omega formula. So omega is equal to VA by IA, which is equal to VB by IB, which is equal to VAB by IB. So this is the formula. This is the formula which is used to find the angular velocity, right. So you can see where omega is the angular velocity of the link and VAB can be easily be found. That is omega into IA and omega into IB. Right. Next important thing is that what are the important properties of the instantaneous center? What are the important properties of instantaneous center? At the instantaneous center of rotation, the rigid link rotates instantaneously relative to another. That? So at the instantaneous center of rotation, one rigid link rotates instantaneously relative to other. The second important property is that the instantaneous center is the point which the body has pure rotation, right. So this is very important point. At the instantaneous center, the body is assumed to be having pure rotation. Hence the body which has a straight motion, the instantaneous center lies at infinity, because when you assume that the body is rotating with any point which is the instantaneous center, so naturally it is of case the pure rotation. If you assume the body is rotating or the body is moving in a straight line path, naturally its instantaneous center lies in infinity because the body is moving in the straight line. And the third important property is that, what is that? So the two rigid links which have no linear velocities related to each other, at this center have the same linear velocity related to the third link or any other link. Right? So the two rigid links which have no linear velocities relative to each other at this center have the same linear velocity relative to the third link or any other link. These are the important properties of uh, instantaneous center. These properties should remember, they will be helpful for doing the analysis. The next one is types of instantaneous centers. Types of instantaneous center. Generally, there are three types of instantaneous center that we come across. Number one is fixed instantaneous center. Second one is permanent instantaneous center, and third one is neither fixed nor permanent instantaneous center. Right? So, in a mechanism, for example, the instantaneous center, the number of instantaneous center can be easily be calculated depending upon the number of links. If small n is, as you can see the formula here, if small is the number of links, then in a mechanism, the number of instantaneous center is equal to capital N, which is equal to n into n minus 1 by 2, where capital N is what? It is the number of instantaneous center, and small n is the number of links. There is a simple example here. As you can see, a 4-bar mechanism having 4 links. So if you just apply this formula and for this 4-bar mechanism, so number of instantaneous centers are 6. How? That is we have the formula n is equal to capital N is equal to small n to n minus 1 by 2, where small n is equal to 4, because it is a quadrilateral or 4-bar mechanism, right? So 4 into 4 minus 1 by 2, which is 6. Therefore, for a 4-bar mechanism, the number of instantaneous centers are 6. As you can see here, right? So I12, you can see this, that is I12, that is I14, that is I14, I14, you can see I23, I34, I13, and so I24. This is what the instantaneous center, how we are going to represent here, right? So any instantaneous center can be, it is represented by I23 or I13 as shown in the figure, right? So if you see this, the instantaneous center I12 and I14, you can see they are at the fixed points, remain the same place because they are fixed for all the configuration of the mechanism, hence they are known as fixed instantaneous center. So fixed instantaneous centers are nothing but, these are instantaneous centers where they remain fixed, they won't be having any motion, that is I12 and I14. Similarly, the instantaneous centers I23 and I34, as you can see here, the instantaneous center I23 and I34, they are termed as permanent instantaneous center. Right? So that is I23 and I34 are the permanent instantaneous centers as they move when the mechanism moves, but the joints are permanent in nature. The third one is the instantaneous center I13 and I14, you can see, right? So I13 and I14, these are neither permanent nor fixed instantaneous center, right? So these are I think I13 and I24 should have been written, right? They are neither fixed nor permanent instantaneous centers as they vary with the configuration of the mechanism, because as the links are rotating, for example, if you consider the crank 2 as rotating, because if you assume the link 2 as the crank 2 is rotating, then naturally the instantaneous centers, right? So the I13, as you can see, I13 and I24, so naturally they will be changing their positions. Therefore, the instantaneous centers are maybe mainly classified as three types. One is fixed instantaneous center. Second one is, as it is written here, permanent instantaneous centers. Third one is neither fixed nor instantaneous nor permanent instantaneous center. This is what the concept of number of the types of instantaneous centers. Next one is the location of the instantaneous centers, how we are going to locate. So for a pivoted joint, the instantaneous center lies at the center of the pin. So naturally, as you have seen in the previous figure, for a pivoted joint, the instantaneous center lies at the center of the pin, and in sliding motion, the instantaneous center lies at infinity, because so when you consider the slider in the slider crank mechanism, the slider is moving in the linear fashion. So when it is having linear motion, the instantaneous center is assumed to be infinity. Similarly, in the case of the pure rolling, when the body is rolling, so rolling contact with the two links, the instantaneous center lies at the point of contact, right? Now, in a slider which is successfully constrained to rotate at the fixed link, which has a constant radius of curvature, the instantaneous center lies at the center of rotation. So, these are the points you should remember, right? So, for a pivoted joint, the instantaneous center is pivoted center only. In a sliding motion, the instantaneous center lies at infinity because it is a linear velocity. The pure rolling, that is the point of the center of the rolling is the pure rolling, that is the instantaneous center. And in a slider, if a slider is successfully constrained to rotate at a fixed link having a constant radius of curvature, then instantaneous center lies at the center of rotation. These are some of the points you should remember while locating the instantaneous centers. Next one is Arnold-Kennedy's theorem. This is with respect to the instantaneous center. It states that if three kinematic links have planar motion, if three links are having the planar motion, then the instantaneous centers of the three links lies in a straight line, right? So this is what the Kennedy theorem states. What the Kennedy theorem states: if three kinematic links are having planar motion relative to each other, if three kinematic links have a planar motion related to each other, then the instantaneous center lie is in the straight line. So the proof will be we can prove that, because depending upon the Arnold theorem only we will be working the concept of the instantaneous centers. So with this basic introduction of instantaneous centers, right? So let us move forward to find how the velocity and acceleration analysis can be done, right? Thank you.